Okay, this is how I solve this puzzle. First, let's look at the rules. Digits and cages must sum to the small clue. So, uh, for instance, this cage adds up to 7. It can't be 1, 6 because there's a 6 in the column, so it's either 2, 5 or 3, 4. This is a 5, so it's either 1, 4 or 2, 3. This is an 8. It can't be it could be a 1, 7. It can't be a 2, 6 because 6 is in the row, but it could be a 3, 5. This is a 7. It can't. It could be a 1, 6, 2, 5, or 3, 4. Okay. So then the next rule is digits on the arrows must sum to the digit in the arrow circle. So this number here has to be the sum of these three numbers. So the minimum these three could be is 1, 2, 3. So the minimum this could be is 6. So this is 6, 7, 8, or 9. And it's the same with all these circles. They all have to be 6, 7, 8, or 9. These two, of course, can't be 6. Then digits may not repeat on either main diagonal. So, of course, in normal Sudoku, you can't have a repeating digit in a row, in a column, or in a box. This puzzle adds that they can't repeat on the diagonal like that. And what that tells us is that these 4 here have to be 6, 7, 8, and 9. They can't. None of those can repeat because if this one sees this one in the column, this one in the row, and this one on the diagonal, it's the same for each of the 4. So those have to be 6, 7, 8, 9, which tells us these two, one of these two has to be a 6. So that means this can't be a 1 and a 6. Now, one of those has to be a 6. Okay, so if one of those has to be a 6, that means either this or this is 1, 2, and 3. But the thing I noticed, and the last rule, of course, is the digit in the gray square must be even. So this one is either 2, 4, can't be a 6, or an 8. Now, the thing I noticed right away is that the way these arrows are laid out. And I wondered if it's possible. So 6 is always going to be 1, 2, 3. So if we got 6, it's going to be 1, 2, 3. 7 is always going to be 1, 2, 4. 8 could be 1, 2, 5, or it could be 1, 3, 4. And then 9 can be 1, 2, 6, 1, 3, 5, or 2, 3, 4. So of the 3 possibilities for 9, 2 of them contain a 1, and one of them is 2, 3, 4. Doesn't contain a 1. So the immediate thing I thought of is it possible for all 4 of these to have a 1 in them? Because that would put a lot of pressure on these corner boxes on where the 1 would go. So if all 4 of these green arrows had a 1 in them, the 1s could not go in these highlighted squares. And then, of course, you'll see that these can't be a 1, of course. And a 1 can't be in a 12. And this can't be a 1. So in this box, particularly 1 is, if a 1 is in every one of the green squares, 1 is forced into here. And if 1 is in there, 1 of course is in here, 1 is in here, that forces a 1 into the 10 box. And if we look up in this box, if a 1 is in the 10 box here, in this box a 1 can't be in there, so a 1's going to have to be in here, which means that there has to be a 1 in one of these, because you can't put, there's 2 columns. If 1 is in one of those and 1 is in one of all those, that's the maximum 1s that can be in those 2 columns. So 1 is in there, which means this is 2, 3, 4. This is 9. This is, no, this, yeah. We're, we're going with the question, can 1 be in every one of the greens? But if a 1 is there, 1 is forced into there, 1 is in there, 1 has to be in here, so that means 1 can't be in there. So we know that of these 4 arrows, 1 of them does not have a 1. Of course, we know that's the 9, because 9 is without a 1 is 2, 3, 4. Following that same logic, because this box not 1 is really restricted, I wondered if a 1 could even be in this arrow, because that forces 1 into here. If a 1 is in, again, if 1 is in this arrow, it forces a 1 here. That means that this is no longer can no longer be 1 and 4. It has to be 2 and 3, which means that if this is 2 and 3, the combinations available to make 10 are severely limited. They can't be 6 and 4 because there's 6 there. They can't be, because this is 2 and 3, they can't be 3 and 7 or 2 and 8. So the 1 is forced into this 10. So that means if the 1 is here, again, if this has a 1, this is a 1, that forces a 1 into the 10. And we've already seen that 1 has to be in here, which forces a 1 into this, meaning this doesn't have a 1. It's a 2, 3, 4. And this is a 9. If that's a 2, 3, 4, though, this is forced to be a 1. But we know it can't be 1 under this assumption. If a 1's in there, 1 is there, this can't be a 1. This is a 2, 3, 4, that's a 1. There's nothing to go in that box. So that means this arrow cannot have a 1 in it. So that means it's a 2, 3, 4. And this is a 9. And then once we get that, we know this one's a 6 because one of those 4 on the corners here have to be a 6, and that's the only one left, which means this is a 1, 2, 3. That can't be a 2, 3. So that can't be a 4, 5. This can't be a 3. That can't be a 5. Okay, so then we know that one of these is a 1. One of all these is a 1. So this can't be a 1. And this can't be a 4. So 1 can't be in there, 1 can't be here, 1 can't be here. Let's see, let's do some more narrowing down. 1 can't be here. So one of those is a 1. And that means one of these is a 1, but that one can't be a 1. So this is a 1, this is a 4. Which means this can't be a 7, because 7 can only be made in 3 digits with 1, 2, 4, but the 4 is already used. So this is, so that means this is an 8. By the way, this can't be a 9. So this is an 8, but it can't be 1, 3, 4 because 4 is already used, so it is 1, 2, 5. This is a 7. That means this is 1, 2, 4. This can't be 2 or 4, so this can't be 3 or 5. So this is either 5, 2, or 2. 4 is already used, so that's 2. That's a 5. Let's see. One has to be up here, but it can't be in 12, so that's a 1. This can't be a 1, so this can't be a 7. So this combination, the only thing that's left, can't be 1, 9, it can't be 3, 7, it can't be 4, 6, so it has to be 2, 8. and 2 is used up in this column, so that's an 8, that's 2. This is 3, 5, 9. 5 can't be in there, so that is a 5. So these two in the row, the only thing left is 7 and 8. So this can't be a 7 because to make 12 we need the 5. So this is an 8, this is a 4, this is a 7. So this is a 3, 6 left. 3 is used in the column, so that's a 6, that's a 3. This is a 7, 8, 9. This is 3, 5, 6. 6 can't be there. Where does 6 go in this box? So it can't be in this, can't be in that, can't be there. So one of those two, it can't be there because the diagonal, so that's a 6. This can't be a 6, that is a 6. All right, there's a 7, so this is a 5, this is a 3, this is a 2, this is a 5. 2. So 2 is here, 2 is here. One of these has to be a 2, so this is a 2, 9 pair. 2 can't be here, so that's a 9, that's a 2. This is a 1, 4, 7, 8. 1 can't be in there, so that is a 1. This can't be a 4 or an 8, so that's a 7. This can't be a 7, and it also can't be a 4, so that's an 8. This is a 5, 9. This is a 1, 7, 8. This is a 4, 7, 8, 9. This can't be a 1 now. So this is a 1. That makes this a 9. These two can't be 9. This one can't be 4, 8, so that's a 7. This can't be a 7. Oh, and it can also can't be an 8. So oops. So this is a 4. So we got 3 and 6 left. This can't be a 3, so it's 6, 3. This can't be 4, 7. This is 5, 4, 5, 7. So here we've got 3. So this is a 9. This is 3. This is 3, 7, 8. This is 4, 9. This one here, let's see. Oh, the diagonal. So this diagonal is only got 1, 2, 5 and left. This diagonal already has a 5 and a 1, so this one has to be a 2. This can't be a 2. This can't be a 2. Can't be 2. Can't be 2. This diagonal only has 3, 4 left. So that leaves, 4 is used in the box. So this is an 8. So these two have to be 7, 9, which means this can't be a 7. This can't be a 9, so it's a 5. This is a 9. That's a 1. This is an 8. This can't be an 8. So this can't be an 8. And it also can't be a 7. So that's a 3. This can't be an 8, so that's a 7. That's an 8. 7, this is 1. 7, 5, 1, 2, 5. This can't be 2, so this is a 2. That's 4, 3, 4, 3, 9, 4. So now 4 can't go there and a 1 can't, so that's a 2. That can't be a 2. This can't be a 2, so 2 is there. This is a 3, this is a 1. 4, 1. can't be a 4, can't be a 4. That is a 4. This is a 9, 8. This is a 5, 3. This can't be an 8. This can't be an 8 or a 9. So it's 7, 9, 8. This has to be 9. This is 7, 5, 7. And there you go. Now, somebody else that I saw pointed out another logical path to breaking into this. If you look at that row, by the way, I think this logical path is more complicated, but it definitely works. If you look at those, that's 4 sets of 1 to 9. And if we look at this box, this box, this box, and this box, color those purple, that's also 4 sets of 1 to 9. So obviously two groupings of 4 sets of 1 to 9 are the same digits. So if I remove, for instance, this digit from the purple, since it occurs, this one occurs once in the green and once in the purple, if I remove that from both the purple and the green, then the purple and the green are still the same. And I can actually do that with all of the squares where purple and green, that cell occurs once in the purple and green. Now, the purple and the green are still the same digits. Now, I didn't do it on these because this one occurs twice in green but only once in purple. So if I remove 1 on these 4, if I remove 1 purple and 1 green, it leaves 1 green. So if I do that, now the purples, which there's 16 of them, are exactly the same digits as the 16 greens. So this is called set theory. I think it's kind of complicated, but it can help you solve some complicated puzzles. So if you look at these 4, again, those are 6, 7, 8, 9, as explained in my solve of it. Those 4 in purple have to occur in green somewhere. Well, they can't occur on the arrows because 6, all of these green arrows see a 6. So this one sees that 6, this one sees that 6. So every one of them sees a 6, and you can never put a 7 or 8 or 9 on a 3-cell arrow because so if I put a 7 there, I'd have to put 1 and 1 to make this a 9, and obviously that breaks Sudoku because you got 2 1s in the same column. So those 6, 7, 8, and 9 have to go in the green somewhere, and the only places for them to go are here. So these have to be 6, 7, 8, and 9. These two obviously can't be 6. Then, if you look at the diagonals, you'll see that 6, 7, 8, and 9 are already taken up on both diagonals. See? So that means that every other digit on both diagonals, oh, come on. Every other digit on both diagonals is actually a 1, 2, 3, 4, 5. And then that forces this middle box that these 4 are 6, 7, 8, and 9. Well, this one can't be 6, and it's also even. So it has to be an 8. These two can't be 6. That forces this one to be 6. It's the only one left. These two can't be 8. So 7 and 9. And then you can follow some other logic, but that's a way to break in and it gets you some digits. But I think the other way is simpler way to solve it. So that's how I did it.